The next objective in this section is to solve quadratic equations by using the quadratic formula. So we must begin by actually saying what the quadratic formula is. And it's stated as this. It's actually a theorem. We're saying it's a definition, but it's a theorem. The quadratic equation ax squared plus bx plus c equals 0 for a not equal 0. So we actually have to have a quadratic, an x squared term. A cannot be 0. Where a, b, and c are real numbers, can be solved by using the quadratic formula given by x, our solutions, is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that divided by 2a. Now, there's lots of ways to remember that, but I'm just going to state this here and make sure that we are going to use it properly. So a few notes that we need to recognize are we need our equation to be in standard form. Standard form with a constant term over here on the right-hand side of 0. That's our first note. We have to do that before we can identify what a, b, and c are. Also, make sure that if you're missing any terms, a good example is missing an x term. Then we actually have to fill those in. We have to put in use zero coefficients to have those before we can actually identify a, b, and c. Now, whenever we're simplifying our expression to actually determine what our solutions are, we need to simplify our radical first and then reduce if possible, as we've done previously. Solve the following quadratic equation by using the quadratic formula. First thing we need is it needs to be in standard form with a 0 on the right-hand side. So I'm going to write this as equals 0, and this will be 9x squared minus 3x minus 20. Notice I'm subtracting that 20. I'm moving it to the left-hand side. So we see that a equals 9, b equals negative 3, and c equals minus 20. That's important. So we will use our formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Replace those values. So x equals negative b. That's the opposite of b. So I'm going to write that as negative 3. But in reality, we're going to treat that as if it's a positive. All right, then we've got negative 3 squared minus 4 times 9 times c minus 20. All divided by 2 times 9, which is our a. So we have 3 plus or minus the square root of something divided by 18. Now underneath that radical, I have 3 squared, so that's 9, minus 4 times 9 times negative 20, which is 729. And actually, 729 is a perfect square. Square root of 729 is 27. So this is 3 plus or minus 27 divided by 18. Now we will reduce this by saying x equals 3 plus 27. That's where our two solutions come in. 3 plus 27, that's 30. 30 over 18, or 3 minus 27, which is negative 24 over 18. So we need to reduce those. That will be 15 over 9. Oh, that reduces more. All right. That is 5/3. And negative 24 over 18 reduces to be negative 4/3. And those are our solutions. Now, for our next example, we first note this is already equals 0. We have a quadratic expression equals 0. Quadratic expression equals 0. So we can go ahead and identify that a is 2, b is negative 6, and c is 1. I'm going to keep writing my formula for a little while. So x equals the opposite of b, so that's going to be positive 6 plus or minus the square root of 6 squared minus 4 times a times c. 2 times a. All right, so we have 6. Let me just go back here and put this in. Negative, negative 6. The opposite of negative 6. This will be positive 6 plus or minus the square root of something divided by 4. Well, 6 squared is 36. And that's 4 times 2 times 1 is 8. So this is the square root of 28. Now I'm going to go off to the side here. 28 is the square root of 4 times the square root of 7. So that is 2 root 7. All right, 6 plus or minus 2 root 7 divided by 4. Now we can only reduce this if a 2, or whatever value, divides into every term. In this case, a 2 divides into every term. So I'm going to factor out a 2. 3 plus or minus, that would just be root 7 divided by 4. And the 2 simplifies with this to be 1. So that means that x equals 3 plus or minus root 7 over 2. Of course, we could write that as 2 solutions. All right, for our next example, 5x squared minus 3x plus 1. It's already equals 0, so we can go and identify a, b, and c. A is 5, b is negative 3, and c is 1. Now, for our equation, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that means the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4ac. About 2 times 5. So that's positive 3 plus or minus the square root of something divided by 10. So that would be negative 3 squared is 9 minus 20. That is negative 11. Well, it doesn't look like we can simplify the square root of negative 11 any. However, we can write that with an I. So this is x equals 3 plus or minus I root 11 divided by 10. And nothing is divisible by, or they don't all have anything in common, so that is our simplified, our 2 complex. Notice there are 2 complex solutions.